Okay, so this is page 4 of the volume of Revolution Notes. And so what we're going to do now is move away from disks and start looking at washers. And so one of the things that you want to note about washers is that as we revolve, there's going to be a hollow center. So for example, um, I don't know, this little espresso mug, right? You can find the volume of this glass, and then there's this volume of this empty space. So, kind of what we're going to do is we're going to find the volume of this glass as if it were completely filled in. Then we're going to find the volume of the empty space, and if we subtract the volume of the empty space from this total volume, we're going to get how much that outer rounded shell, um, how much space that would take up. Okay, so the way we start with this is ultimately uh, when you revolve this right here is going to be an empty space, kind of like if I took a little line right here, drew a little dot, you can kind of see that this right here would be a circle, and this would be representing the empty space. So it'd be a circle here, circle here. So all of this would be white, this would be empty, and so we're going to focus on that one. And then the actual area would be something down here, right? And then you create that kind of like circle. Now, it extend further down, I just don't have enough space. Um, Anyway, what's the shape of this cross-section area? This is going to be what we call a washer. And the way we figure this out is we're going to find the area of everything filled in minus the area of the empty space. And what we end up with is something like this, with a circle space. And so here is a little r, and from the center out, that'd be big R. And we would find this area right here. So it's a very similar problem you did in geometry. We're just adding up a lot of these, giving it a little bit of width to give it three-dimensional volume, and then adding up all of those. And then as we add up, it's going to create this weird kind of like bowl-like shape. Okay. Let's see. Okay, so the way we actually figure this out is we just do two disks essentially. We do one with the blue, we do one with the red, two disk problems, and then we just subtract the two, and that'll give us our answer. So, first thing you want to do is you want to establish your big R, and you want to establish your second disk problem with a little r. And this is both in relation to, in this particular case, this is the axis of rotation. I'm going to rotate around the x-axis, y equals 0. Okay, so once we do that, so what's the shape of the cross-section area? We call it a washer. Find the area of the cross-section. And so what this will be is pi big R squared minus pi little r squared. If we wanted to write that whole thing out, this would actually be pi. And remember how we figure out what r is? It's always going to be function minus the axis of rotation. And so in this particular case, it'll be um, cosine and then the small function down here would be sine. Okay, so in our particular case, it'll be cosine. So back up. So this one will be cosine x minus the axis of rotation, which is y equals 0. So we put 0 here, squared. Then we do minus pi sine x minus 0 as well, squared. So this is pi big R squared minus pi little r squared. So now this is this right here, the circle with the hole cut out. That's what the area is. Okay, what's the width of the slice? Well, we're going to give, just like we did before, we're going to give the width a little bit of thickness, dx, in this particular case. That gives it volume. Okay? And so we take this area. So this right here is area of the washer times the width equals volume of one washer. Okay? Now, what would the sum of an infinite number of these washers be? Well, like we always do, we take an integral. And so our integral will go from x equals 0, and we just start to fill it in. Pi, in this particular case, cosine x minus 0 is just cosine x, so cosine x squared minus pi sine x, okay, squared dx. All right, so then the only thing we're missing is what this upper limit is. What is this going to be? Well, it's the point of intersection. So if we think that it might be like 1 or something like that, we don't know for sure. So you actually have to do the math. You can either type it into your calculator and find the point of intersection, or when is cosine and sine, what x value will make them the same? And that happens at pi over 4. And the y value, when you plug it into either of them, will be square root 2 over 2. But what I really want is the pi over 4 part. So that's going to be our lower limit, pi over 4. Okay? All right. So one of the ways that you kind of want to think about this are, this right here is the kind of like outer function, the function that's further away from the axis of rotation. Okay, that's what your capital R, it's your bigger radius essentially. Your little radius is the inner function, the one closer to the axis of rotation. Okay, so that's how you want to think about those. But ultimately, it's just two disk problems. One disk minus another disk, so one full complete area. You find the volume of the empty space, you subtract the two, whatever left over is your volume. All right, that's the end of page 4.